And that's it. All right, guys. Take a deep breath. Get settled. Today's the day. So guys, this is the day that this entire unit has been building up to. We started the unit by blowing your mind. We watched those videos, and if nothing else, you have an appreciation that electrons are unlike anything you've ever seen before. Then, guys, we did the flame test lab, and we built up the Bohr model of the atom. Would you all agree that on Monday we did a pretty effective job of tearing the Bohr model apart? Why didn't the Bohr model work? Because electrons are not particles. They don't behave that way, and to try to study them that way is a dead end. Thank you, Heisenberg. Now, guys, it's time to pick up the pieces. So the question is, where are the pieces? And guys, the answer is right here. Guys, grab your class notes and let's be really sure what's going to happen today. And guys, this may be a good time to grab a pencil or pen because I'm going to draw your attention to the important parts. So guys, here's what's going to happen today. I'm not going to teach you anything. I know that sounds weird because you know today's an important day. But guys, I'm not going to teach you anything today. What I'm actually going to do is ask you a series of questions. And guys, all of the questions you know the answers to because they're all right down here at the bottom of your notes page. And as you are answering these questions, you are going to be writing those answers onto this page. And then, guys, as you answer these questions, there's going to be this magic moment where you're going to go, no way. And all of a sudden, all of this stuff over on the wall is going to leap off of the page and make sense. Guys, understand if it doesn't immediately leap off the page for you, I promise you it will. I've never had a student not be successful with this material. Trust me. But guys, and then after that leaps off the page, then we're going to talk about the extra credit assignment. And then guys, for the rest of the day, we're going to grab our periodic tables and we're going to do some interesting stuff so that you all can make sense of this without having to memorize anything. You guys ready to go? Okay, so guys, grab your class notes, the one from last time, and let's make sure you can all find the important stuff. You ready? So what is the important stuff? Well, first of all, this, and you may want to underline these things. So guys, looking underneath where it says principal quantum number, see where I'm looking in last time's notes? Guys, you need to know this. The values go from 1 to 7. You may want to underline 1 to 7. Then guys, the other piece here that you need to know is the 2n squared rule. You may want to underline that as well so that your eye can quickly fall to it. And now guys, let's remind ourselves, what does the 2n squared rule tell us? The number of electrons in an energy level or a cloud or a shell, and that goes up to 7. You good? Okay, now go down to sublevel. These are the things you need to know. The number of sublevels in an energy level is n. You may just underline energy level is n. Then guys, the next thing that you need to know is the names of the sublevels, and they are named S, P, D, and F. You may want to underline that if you need something to draw your attention to it. You guys doing good so far? Okay, now let's go down to orbitals. Guys, the important thing that you need to know is 2 electrons go in an orbital. Then guys, finally, the last thing that you need to know is what is true of those 2 electrons in an orbital. Guys, what is true of those 2 electrons? Opposite spins. And guys, here's what we're going to do. We are going to, in a minute, talk about them as being spin up and spin down. So you may want to underline the words up and down, reminding yourselves that electrons actually do point in opposite directions when they pair up in an orbital. You guys good to go? Almost. I'm happy to wait. How about now? Okay, so now guys, do this. Take your notes page from yesterday, slide it to the side, but keep it in your field of view. And now pull in today's notes page And we're going to start annotating today's notes page. So guys, can I get rid of this? Okay, so guys, it looks like this, right? So here's what you need to do to make sense of this. We need to do some labeling. And so guys, the first thing that we need to do as we label this thing is we need to remind ourselves what N, L, and M represent. So glance over at your notes from last time. We're just going to call those last time. Glance over at last time and remind yourself, what does N stand for? Energy level. So write it down. Guys, N is the energy level number. It tells you the size. What is L? Sublevel number. It tells you the shape. And then guys, what is M? It's the orbital number, and it tells you the orientation. And guys, all this is on the board. N is the energy level number. It tells you the size. L is the sublevel number. It tells you the shape. M is the orbital number. It tells you the orientation. Now, guys, one more thing that you're going to want to do to get up to speed here. See where your paper says, it does, right? See where it says nucleus down at the bottom? Do this. Draw a half circle over that to indicate that that's actually the nucleus, and it's like a circle. It's a sphere. You guys good? Y'all caught up with me? I don't want to go too fast, but I want to make sure that Are we okay? Okay. So guys, in order, and this is where all your notes are going today, right? In order for you to understand what you're doing, you first of all need to know what you're looking at. So guys, the fact that the nucleus is down here at the bottom would tell you, what are you looking at? It's an atom, right? It's got a nucleus, and then we've got these lines that are energy levels, but I don't think that's clear enough. So guys, let me help you understand what you're looking at. Are you guys familiar with the idea of a core sample? Have you heard of that? Okay guys, if you don't understand what a core sample is, let me explain it to you this way. If any of you have apple trees in your backyard, and we do, guys, about this time of year, a little bit earlier, we go out in our backyard and we pick these apples. But frankly, what we like to do with them is we like to turn them into applesauce. So what we do to turn these things into applesauce is we peel them and we put them in the little spinny thing that peels, and you get the big old long peel. But then guys, the next thing you got to do before you can make applesauce is you got to take out the core. Have any of you ever cored apples? You know how that works, where there's that long metal tube and it's hollow and it's got teeth at one end and it's got a handle at the other, and you start at the end of the apple with the stem and you put the stem inside the tube and then you twist and drive the thing through the apple and it goes down through the middle of the apple and you pull it out, and then what's inside that metal tube? The core, and then you can look through the apple, right? Well, guys, imagine, or if you can't picture that, if you haven't had the experience, this is what we're talking about. So you take an apple and you drive a metal tube down through the apple. Now, guys, if you were actually coring the apple, you'd go all the way through and out the bottom. But we're only going to core it to the middle. But then imagine, guys, that we could pull out this core of the apple. Literally, if we could lift this out. See what I'm saying? And then if you could look at this, this is what is called a core sample. So by taking a core sample of an apple, you now know what's inside the apple. There are the seeds, which you're going to find out are kind of like the nucleus. And then you've got the flesh of the apple, and then you've got the stem of the apple, and that, does that make sense? That's a core sample. Well, guys, imagine doing the same thing to an atom. So we understand that atoms kind of, and do you like that those look like clouds? It was really cool when I figured out that I could make things cloud-like. But guys, when we look at atoms, what's in the middle? The nucleus. And then we've got one cloud. That's energy level 1. Then we've got a bigger cloud, energy level 2. And guys, when you think of the clouds, what are you thinking of? fan blades, right? Are they really these big old spheres? No, but they behave that way because electrons behave like big volumes because they're moving. So we've got one fan blade cloud. We've got another fan blade cloud. We've got another fan blade cloud. And guys, if we take a core sample of this, notice what we've got. We've got this down here, which is what? Half the nucleus. And then we've got these boundaries, which are the edges of the clouds. Do you get it? That's this. Do you understand? So guys, if you want to maybe relate that to this, the idea here is that this is a cloud, this is a cloud, this is a cloud, this is a cloud, but all we're representing are just that little itty bitty bit of it. You get the idea? Was that helpful? Okay, so guys, core samples. Now we're going to get to business. And guys, here's what we're going to do. We are going to spend 10 minutes and we are going to flesh this out. So guys, sort of you're going to have, your eyes are going to be skipping back and forth like a tennis match. So guys, what I'm going to do is I'm going to ask you questions. The answers to those questions are on here at the bottom. But as we answer the questions, you're then going to be drawing on here. You ready to go? Okay, so guys, question number 1. What do these lines represent? The clouds. How many different sizes of clouds, this is on last time's notes, how many different sizes of clouds can there be? 7, right? So guys, let's number the ones that I put on your paper. So we're going to go 1, 2, 3, 4. But now you're saying, wait a minute, I thought this went up to 7. Well, guys, watch what comes in right here. It does go up to 7, but we are only going to do this with the first 4. This could go up to 7. I had considered making the extra credit question extend this diagram out to 7, but it would become impossible. So we are only going to go through 4. You guys good? Okay, now the next question. How many electrons can be in each of these energy levels in each of these clouds? And the answer is not 2, because that's the orbitals. How many electrons go in the clouds? What is the rule that tells us? And it's, yes, the 2n squared rule. So guys, we are going to write those numbers on the lines. So how many electrons go in the first energy level? 2. How many electrons go in the second energy level? 2 squared is 4, double it is 8. How many in the third? 18. 3 squared is 9, double it is 18. How many in the fourth? 4 squared is 16, double that is 32. You guys with me? Okay, so now guys, we are going to do some amazing logical thinking. Remember, I haven't taught you, the only thing I've taught you so far is what a core sample is, right? I'm just asking you questions. You knew this went 1 to 7. You knew the 2n squared rule. So now what we're going to do, guys, is we're going to turn our attention down here, and I'm just going to keep asking you questions. So guys, next to energy level 1, draw an arrow. And forgive me that this is so low on the board. Just draw an arrow. I had to make this as low as I could because we need the space. So guys, where did that arrow take us? Well, it took us from energy level over here to sub-level. So guys, allow your eye to look at yesterday's notes. What do we know about sub-levels? How many sub-levels are in an energy level? N. What does that mean? It means the first is 1, the second's 2, the third is 3. But we also know their names. The first is 1. What is it? S. Second's 2. SP. Good. You guys good? Okay. So guys, let's do this. Here's what we're going to do. And do this right. Underneath sub-level, draw yourself another line. So, how many sub-levels are in the first energy level? 1. That's why we drew one line. Now, what kind of sub-level is it? It is an S, so label it as such. So guys, that line represents the 1s sublevel. Okay, now guys, this is an interesting piece of logic. You ready? Think about this. I live in Linden, and right now in Linden, they are building, they're tearing, can you believe Stratton sold their orchards? Now, I never thought the day would come, but guys, they're tearing down orchards in Linden like crazy. And right at the top of my street, they actually just tore down this orchard, and it turned into a new neighborhood. Ivory Homes is going crazy. But guys, this is the idea. So Ivory Homes comes in and they blow up the orchard, right? And then it's time to start building stuff. So what's the first thing they build? Roads, right? So guys, we've got a neighborhood, and here's the thing, they're just getting started, so there's only one road. But guess what? They've already built 2 houses. It took them, it was like 3 weeks, and houses are going up, road houses. So guys, here's the idea. They're building a neighborhood, right? How many houses are in the neighborhood? 2. So how many houses have got to be on the only street that's there? 2. There's nowhere else to build them. Do you understand the idea? If you've got a neighborhood with 1 street, and if that neighborhood's got 2 houses in it, both of those houses have got to be on the only street in the neighborhood. Do you understand the logic? Apply it to this. Guys, we've got an energy level that has 2 electrons, like the houses. So the energy level is the neighborhood. We've got an energy level that's got 2 electrons in it. But that energy level only contains 1 sublevel. So how many electrons have got to be in the only sublevel that's there if we need 2 electrons in the whole thing? 2, both of them. So guys, there's 2 electrons in the S sublevel. Now guys, do this. Ready? We're not going to draw an arrow, but mentally you need to go over here to orbitals. Look at your notes from last time. What are orbitals? The clouds, right? They are the clouds. How many electrons can go in a cloud? 2. Now guys, think about this. If each cloud, you notice how I'm just asking you questions? Guys, if each cloud can hold 2 electrons, and there are 2 electrons in this sublevel, how many clouds will it take to hold those 2 electrons? 1. And guess what? It looks like this. Guys, draw this underneath orbital right next to the 1s, and I'll move it up so y'all can see it. There's the cloud. And guys, before you start drawing, let's make sure, and make this about 1 inch big. So guys, here's what you're drawing. What do the 3 axes mean? Do you know? We've got this guy, this guy, this guy. What does that mean? 3-dimensional, up and down, left and right, in and out. What you are drawing is a spherical cloud. And you'll notice the dots. We know what the dots are. Those are the probabilities of finding the electrons. And we know that this is actually most probable right there around the nucleus, and that's like the fan blades. So guys, here's the idea then. What you're going to draw, just do this. Just draw up and down, left and right, in and out, and a circle which you understand to be a sphere. Now guys, here's the hazard. Right now you're looking at this and you're going, okay, I understand the answers to these questions. I get the 2n squared rule. I get 1 through 7. I get SPDF. I get 2 electrons in an orbital. But good night, what just happened? Guys, the thing that's really weird, and you just got to trust me on this, if you're feeling right now like you don't understand what this is all about, the best way to address that is just keep going. Because what you're going to find out is we're very quickly going to fall into a rhythm, and all of a sudden this rhythm starts to make sense. So guys, did you all draw your 3 axes in your circle? You're good? All right. So now guys, here's what we're going to do. I'm actually going to take my circle away, and we are now going to go up to the 2nd energy level. You guys ready? So allow your eyes to go up here. So now we're in the 2nd energy level. Draw an arrow. Okay, here come the questions. Guys, and follow the arrow to sublevels. Second energy level, how many sublevels? 2, what are they? S and P. Now guys, watch, don't do this yet. So now, if there are 2 sublevels, how many lines are we going to have right here? 2, right? But guys, be careful. They go like this. So if you allow, extend this line over, one of those lines is a little bit below, and one of them is a little bit above the energy level 2. So draw it like I did. Okay, here we go. You ready? What are the 2 sublevels in the second energy level? S and P. S and P. Notice, guys, that we call them the 2S and the 2P because they're in the second energy level. Now, guys, check this out. This is cool. How many electrons are in the 1S sublevel? 2. So guess what? There's also 2 in the 2S. Now, guys, you ready? Let's see if you can figure this out. How many have got to be in the P? Ooh, how'd you get, Steve? Talk to us about 6. Good. There's 8 total. Imagine our neighborhood has 8 houses and 2 streets. If 2 houses are on one street, how many have got to be on the other one? 6, right? There's 6 electrons in the other for a total of 8. Now, guys, let's look at orbitals. So we already know that the s orbital is a sphere and it holds 2 electrons. So guess what? The 2s orbital is also a sphere. But guys, before you draw anything, do this. How is the 2s different than the 1s? It's bigger. So here's what you're going to do. You are going to draw boom, 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 but what you draw there, make it bigger than what you drew for the 1s. It's just bigger. Okay, now guys, check this out. This is where this gets really crazy. You ready? Y'all got it? Now let's go to the P. How many electrons, are you guys ready? I don't want you to miss this. So did you draw your circle? Okay, so guys, now let's look at the P. How many electrons are in the P? 6. Now if we come over here to orbitals, how many, and let's remind ourselves, how many electrons in an orbital? 2. So if we need room for 6 electrons, and if each orbital can hold 2, how many orbitals do we need to hold 6? 3. Does that make sense? And guys, check it out. There are 3 p orbitals, but they are not spheres. Do you remember what they look like? Oh man, they're figure 8s. Draw them. Yeah, they're figure 8s. Is that too dark? Yeah, guys, they look like this. They are actually figure 8 shaped. Now, guys, as you're drawing these, let's be really clear about this. They're all really around the same nucleus, right? So why did we separate them into 3 separate drawings? What do we find out? What does it mean that one's like this and one's like this and one's like that? Guys, what that means is this. One of these is up and down. Watch, say these pens are the figure 8s. One of them is up and down. One of them is left and right. One of them is in and out. They actually orient like this. So what are those angles? Right here, what are these angles? 90 degree angles. And guys, why would these orbitals do that? Why would they orient 90 degrees to each other? Exactly. Why wouldn't they want to overlap? Because they're all made of electrons and they repel each other. So guys, when you draw this, it's important that you include the idea that these things orient 90 degrees to each other because of repulsion. So guys, catch up with me and then we're going to have a little conversation. Y'all caught up? No? All right. You guys are very thorough artists. I appreciate it. You guys good now? I'll be up here if you need me. How about now? You guys good? Someone help Savannah, please. Are you okay? Yeah. All right. Hunter, keep an eye on her. Okay, so guys, check this out. Just stop writing and just enjoy this for what it is. You ready? How many electrons do we have here? Well, we've got 2, and these 2 electrons are in a little bitty sphere that is the 1s orbital. Then, guys, we've got 2 more electrons that are in a bigger sphere that is the 2s orbital. Then we've got 6 electrons in these figure 8, we call them dumbbell, in these dumbbell-shaped p orbitals. So we've got 2, 4, 6, 8, 10. 10 electrons. So guys, if we've got 10 electrons, what element does this represent? Well, it represents neon. But guys, we understand that these electrons are not all spread out. They're all around the same nucleus. So what do we end up with if we take this cloud and these 3 clouds and put around the same nucleus? What do we get? Guys, we get this. No. You already did. Savannah's like, oh crap, do I have to draw this? No, guys, you already did draw this. Check this out, guys. This is really interesting. So what does this ball represent right there? The 1s orbital, and how many electrons are in there? 2. And this represents the 2s orbital, and how many electrons are in there? 2. And then here's 1, 2, 3. Oh, golly. Don't laugh. 1, 2, where am I at? 3 orbitals, and which ones are those? The p orbitals, 2 electrons in each, 1s, 2s, 2p. Boom, that's neon. Guys, that is what neon actually looks like. Now pull this together in your head. How do we know that this is an s orbital? Because it's a sphere. Now guys, notice the difference. What is the difference between the 1s and the 2s? The 2s is bigger. But now guys, watch this. What is similar about the 2s and the 2p? What's similar about them? They're about the same size. Did you know which one's a little bit smaller? The S is a little bit smaller than the P. Guys, that's why you drew the S a little bit below the P. You get it? You drew, look at your notes. You drew the S a little bit below the P because the S is a little smaller than the P. But now guys, check this out. How are the S and P different? Their sizes are about the same. How are they different? Their shapes. The S's are spheres, and the P's are these dumbbell-shaped figure 8s. And you bring all of that together, and you end up with neon. Isn't this crazy? It gets better. Guys, check this out. You ready? First of all, this. Guys, we're going to put Savannah out of her misery. Yeah. So guys, you understand the S's and the P's and stuff, right? But imagine having to draw spheres and figure 8s anytime you want to talk about electrons. We're not going to do that. Guys, here's what we're going to do instead. We are going to replace, going back to your notes, we are going to replace the spheres and the figure 8s with, oh, sorry, I'm drawing white dots. Guys, we are going to replace those with boxes. Go ahead and draw those in right now. We're going to replace them with boxes, with squares. So what does that bottom box represent? Well, guys, this bottom box down here actually represents a sphere. We're just not going to draw it that way. And this represents a sphere. We're just not going to draw it that way. And this represents 1, 2, 3 figure eights. We're just not going to draw them that way. We're going to draw them as boxes, but the boxes represent the clouds. So if the boxes represent the clouds, what do the arrows represent? The electrons. And what is the importance of the fact that we draw the electrons as arrows pointing in opposite directions? Up and down spins. You starting to get it? Yeah. So guys, why do we draw them as boxes? The reason we draw them as boxes is because it communicates to us that this really isn't what they look like. They're not boxes. They're spheres and dumbbells. We draw them as boxes because it clearly tells us this isn't what they look like. You guys good? All right, guys, let's keep going. This gets better. Third energy level. We're moving up. Third energy level, how many sub-levels? 3. They are S, P, and D. But guys, stop. Look at how we draw these. We're going to draw an arrow. Oh, come on, draw my arrow. Oh, yeah. Hold on. I think I'm drawing white dots still. So, guys, we're going to draw our arrow. And then, guys, how many lines do we need for the third energy level? 3. Yes, but, guys, watch how we do this. This is important. You're still going to go below and above. But then, guys, check. Don't draw until you get this right. This guy right here, which you know will be the D, right? SPD, it should be just below the fourth energy level. Go do it. You guys got it? Okay, guys, here we go. Label them 3S, 3P, 3D. So here we go. How many electrons do we know go in the S? 2. How many electrons do we know go in the P? 6. How many electrons must then be in the D? Oh boy, 18 minus 6 is 10. Do you see it? 18 minus 2 minus 6 is 10. 18 minus 2 minus 6. 10 plus 6 plus 2 is 18. All right. So guys, ready? Now let's do orbitals. What is the shape of the 3s orbital? A sphere. How does it compare to the 2s orbital? Bigger. Draw a box. Now, what about the 3p's? How many orbitals do there have to be? 3. What is their shape? Dumbbells. How do they orient? 90 degrees to each other. Why? They repel. Draw 3 boxes. Now, guys, check this out. How many orbitals, we're now talking about the 3D, how many orbitals do we need to house 10 electrons? 5. So we would expect there to be 5D orbitals. Guess what? There are, and they look like this. Don't draw them. But guys, isn't that cool that this simple little thing that we're doing on the board predicts that there should be 5D orbitals, and there are. But what are we going to do with this instead of drawing that? 5 boxes. Now guys, let me show you a trick. This is the best way to draw 5 boxes. You ready? Draw a rectangle, break it up with 4 lines. Now you've got 5 boxes. Yeah, go ahead. Last width. Oh, yeah. So you notice that the first 4 looked like sort of like clover leaves, right? And then the 5th one looked like a p orbital with a belt around it. So let's ask a different question. Guys, the question on the table was, why did the last d orbital look different than the first 4? Maybe another question would be, why did they look like this at all? And the answer is, these electrons are trying to do 2 things. They're trying to get as close to the nucleus as they can. because they're attracted to it. But they're also trying to get as far away from each other as they can because they repel each other. And the answer is the easiest way to get electrons to pack together is to put the first 2 in a small sphere, the next 2 in a bigger sphere, the next 6 in the dumbbells, the next 2 in a bigger sphere. So the reason they take on these shapes is because it's easiest. And it turns out that the easiest way to get 10 electrons around an atom is cloverleaf, 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 whatever that was. And that's all they're doing is just trying to get as close as they can. Yeah. All right, guys, you good? You're going to love this. You ready? 4th energy level. 4th energy level has how many sublevels? 4. What are they? S, P, D, and F. Guys, check this out. Ready? Draw your arrow. Oh, yeah. Yeah, that's it. Guys, watch. Oh, man. Yeah. They overlap. Guys, draw the line for the 4s orbital beneath the 3d. Then it goes up from there, 4s, 4p, 4d, and 4f. Guys, it turns out that as these atoms get more and more and more complicated and complex, these orbitals, these energy levels, start to overlap with each other. So they do not simply fill 1st, 2nd, 3rd, and 4th. It's more complicated than that. So guys, here we go. How many electrons in the 4s? 2. How many electrons in the 4p? 6. How many electrons in the 4d? 10. All right, I know you guys, so here we go. 2 plus 6 plus 10 plus what is 32? 14. All right. So now, guys, let's draw our boxes. So the 4s, spherical orbital, bigger than the other 3. We're going to draw a box. Because what if you do this? What if you draw the boxes but don't fill in the arrows because you know they're supposed to be there? Make it faster, right? So now what about the 4p? How many orbitals are in the 4p? 3. What do they look like? Dumbbell figure 8s. Draw 3 boxes. How many orbitals are in the d? How many orbitals are in the d? 5. What do they look like? We saw them just a minute ago. 4 clover leaves and that funny thing. Guys, draw 5 boxes. And then I'll let you catch up. Stetson, how's your brain? You doing okay? Yeah. Understand that if this is getting wacky, it's because you missed last time. You guys good? All right, guys, you ready? You know the answers already. 14 electrons in the F. How many orbitals do we need? 7. And guess what, gang? They look like this. And there are 7 of them. The logical progression of this is just cool. Yeah. Yeah, understand that the colors are just to allow you to differentiate between them. If it was just all blue, it would be a blob. But frankly, a big blue blob would be a better representation because these are the clouds behaving as if they were solids, right? So it really is a big blue blob. Well, it's not blue, it doesn't have color, but they want you to understand that there are different lobes, and that makes them stand out. So guys, what are we going to do with this? We're going to draw 7 boxes. Now, guys, understand we could keep doing this all the way through energy level 7. We're not going to. We are going to stop at energy level 4. Now, you guys all caught up? Here's the extra credit assignment if you choose to do it. It's completely optional. It's due the day of the test next week. Guys, if you want to do the extra credit, here's what you're going to do. So you understand the order to these. It goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, then the 4D, then the 4F, right? Do this for that. Because this only goes 1s, 2s, 2p. Guys, the challenge, and I love that some of you are looking to the east, the challenge is to do this for that. And guys, understand, you can do all sorts of creative things. We had people that did cutouts. We did people that separated them and went all the way up. We had people that combined them together and tried to, as you said, color code them a little bit and go all the way up. We have one with the decoder key. We have one that actually, that's Anna Monson's. It used to be much more symmetrical and then it smushed. Last year, I had somebody that actually did it on a computer. This one's really cool. He actually did this by cutting these out on Mr. Gurr's laser printer thingy. So you've got the 1S and then the 2S and then the 2Ps as if they are shadows. And when you stack them all up, which I'm really struggling to do, you get the sense of depth and just how crazy this really gets. Somebody put these things on transparency film, which was cool. And you've got, it's a flip book, the 1S, the 2S, and you can look down through it and see the craziness. Guys, I love all of these ideas. So, if you are interested in extra credit for this, it's up to you how you choose to represent it. But do you understand the idea? You are going to represent all of this, the 1S, 2S, 2P, 3, all the way through the 4F, but you're going to do it graphically in some way that allows us to understand how they all intermingle, and it's due the day of the test. You're welcome to work on it with somebody, but it can't be more than a group of 2. So questions about the extra credit? You sure? Okay. All right, so guys, I'm not going to mention it again. If you want to do it, that's great. But understand, you don't get to come to me the last day of the quarter and say, Mr. Knappenberger, I didn't do the extra credit. I'm missing an A by 0.2%. Can I now do the extra credit? It's the day of the test or not at all. Yo? All right. Now, guys, here's the trick. Whether you choose to do the extra credit or not, you have to know this. And guys, here's what you have to know. You have got to know the order that these electrons fill. You have got to know 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and up from there. You've got to know 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5f, 6, and all the way up through the entire, all 7 of them. But guess what? You don't have to memorize it. Do you remember that thing that we saw in the Hank Green video where he went 1s, 2s, 2p, 3s, 3p, and then he drew the arrows? I don't know if you remember that or not. Guys, you don't even have to do that. You need to know this order, but I will never ask you to memorize it. You know why? Because guys, every single one of you walked into this room this morning knowing 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and all the way up. And guys, how do I know that every single one of you knew this? It's not, you didn't. You didn't write down the 1s, 2s, 2p, 3s, 3. You wrote down some of it, but not in the right order. How do I know that every single one of you came in here knowing 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on? Because every single one of you owns one of these. Guys, that's the order that the periodic table is in. Let me help you make the connection. You ready? Okay. So guys, grab the thing that you're going to use to write on your periodic tables. So guys, first of all, let's do this. How many energy levels are there on the periodic table? It does not go 1 through 4. It goes 1 through 7. Find something on the periodic table that has something to do with 7. Guys, look. 1, 2, 3, 4, 5, 6, 7. Guys, those are the energy levels. Label them. Each horizontal row on the periodic table is an energy level 1 through 7. Yep. We're going to talk about them in a minute. But if you look, Abby, check this out. Notice that this, Abby said, here, let me do it up here. Abby said, what about the guys down here? Count the numbers. 55, 56, 57, 72. There's a skip in the periodic table, which is this. This row right here should be a tumor right there, but they don't put it there because it would throw off the symmetry of the table, so they put it at the bottom. So guys, what do we now know? Each horizontal row on the periodic table is an energy level. But now guys, go back to your class notes. What are the energy levels broken into? Sublevels. So guys, let's start with the S sublevel. How many electrons are in each S sublevel? 2. Guys, go back to your periodic table and find something on there that has anything to do with 2. Do you see it? Guys, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Guys, this part of the periodic table is the S sublevel. But in order to make this happen, guys, you need to draw helium in over there. Don't cross it out over here, but redraw helium. Just put helium in a 2. Guys, in order for this to make sense, helium has got to be a next door neighbor to hydrogen. What do you know, Britt? It's working. You guys good? All right, so now we've got the S. Could it get better? Check it out. Guys, now we've got the S's, now what do we need? The P's. How many electrons are in the P's? 6. Find 6. Oh, where's 6? 1, 2, 3, 4, 5, 6. Guys, all of this is the P sublevel. Now, guys, we need the D's. How many electrons are in the D? 10. You want to guess how many are in here? There's 10. That is the D sublevel, but label it D minus 1. D minus 1 in parentheses, just like it is on the board. Now, guys, the only thing that we're missing is the F's, and the F's have got 14. Guys, you want to guess how many boxes are down here? There's 14. This is F minus 2. I'll show you. Guys, check this out now. You ready? You now have all the information that you need. Guys, check this out. You now have all the information that you need to say out loud 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, and on up the row. But guys, in order to figure this out, watch this. Don't write this down, but watch. Have you ever played the game Battleship? All right, if you've played the game Battleship, then guys, you understand how this works. What is this point right here? Guys, make sure you play along or you're going to miss this. What's this? 2B. What is this right here? 3D. What is this right here? 4B. What's this right here? 2C. What's this? 1D. What's this? 1A. What's this? Oh, guys. What's this? 2B. What's this? 2C. What's this? 1A. What's this? 1S. What's this? 2S. What's this? 2P. What's this? 3S. What's this? 3P. What's this? 4S. What's this? Hold on, it's a D, but it's minus 1, so 4 minus 1 is 3. So what's this? No, what's this? 4s, what's this? 3d, what's this? 4p, what's this? 1s, what's this? 2s, what's this? 2p, what's this? 3s, what's this? 4, what's this? 4s, what's this? 3d, what's this? 4p. Guess what you just said out loud? Guys, you just said 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Now here's the question. How did I know to go here, then 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 here? I'm going in order. 1 and 2 are in the 1s. 3 and 4 are in the 2s. 5 through 10 are in the 2p. 11 and 12 are in the 3s. 13 through 18 are in the 3p, and it just keeps going. You get the idea? So guys, what are we going to do with this? Well guys, this is what we're going to do. Take your paper and flip them over onto the back. We are going to draw what are called orbital filling diagrams. So guys, across the top of your page, write down the words orbital filling diagrams. We're going to do 3. So guys, the first one that we're going to do, write this down with me, we are going to do oxygen. So guys, it goes like this. Find oxygen. Element 8, you see it? What sublevel is oxygen in? 2p. So guys, we know that we've got to get to the 2p, but we can't just put electrons in the 2p. Where do the first 2 electrons go? Where are they? 1s. So guys, come over here and write down 1s. Now guys, where do electrons 3 and 4 go? 2s. Write it down. Now where do electrons 5, 6, 7, and 8 go? Where is this? 2p. Now, we need a place to put electrons. Where do the electrons go? In orbitals. What does the 1s orbital look like? A little sphere. Draw a box. What does the 2s orbital look like? A bigger sphere. Draw a box. What do the p orbitals look like? Dumbbells. How many are there? 3. Draw 3 boxes. Now guys, we've got to place electrons. You ready? How do we represent electrons? Arrows. Let me show you a trick. Guys, don't try to draw arrows like that. You're going to get exhausted. Draw arrows like check marks. So there is electron number 1. What does it mean that it's pointing up? What does that tell you? The spin, the North Pole's up. So guys, in order for a second electron to pair, which way does it have to point? Down. There's electron number 2. Now guys, let's do electron number 3. It goes here. Then electron number 4 goes here. Now guys, how many electrons does oxygen have? 8. We need 4 more. So check this out. Electron 5 goes there. Now be careful. Electron number 6 does not pair up. Here's the rule. If you've got a sublevel with more than one box, half fill the boxes first. So electron 6 will go here, electron 7 will go there, and electron 8 will go there. And that is the orbital filling diagram for oxygen. Now guys, here's the deal. Some of you right now are going, I think I understand this, but so what? Who cares? And it's a valid question. Guys, don't write anything down that I'm about to do, but let me show you why we care. You ready? Let's do hydrogen. Don't do this, but watch. Guys, where is hydrogen? 1s, right? So I'm going to do a hydrogen atom. And hydrogen is 1s. And how many electrons go in hydrogen? 1. And you know what? That was so much fun. I'm going to do it again. And I'm going to do another hydrogen because the first one was fun. Oh gosh, that second one was fun too. Do you get it? Guys, look. See this empty spot right there? See that empty spot right there? Guess what they do? They shove their electrons into each other's empty spots and they bond. But oxygen's not done because it's got another empty spot, and another hydrogen comes in and shoves its electron in there, and guess what we get? See, guys, that's the point. These orbital filling diagrams in the next unit fit together like jigsaw puzzle pieces to make molecules. That's where we're headed with this. That's why we care. So guys, let's do another one. Let's actually skip, let's skip potassium and let's do copper. We're going to do copper. So we're going to skip potassium and we're going to do copper. And guys, look where copper is. Element, I'll just write it down for you. Guys, copper is element number 29. Whew, this gets a little bit aerobic. You guys ready to go? Check it out. Guys, be careful. Don't say anything until you think. Which sublevel is copper in? D, but it's not 4, it's 3. But guys, in order to put electrons in the D, we've got to go all the way back to electrons 1 and 2, which are where? 1s. Now, where do electrons 3 and 4 go? 2s. Now, where do electrons 5 through 10 go? 2p. Now, where do electrons 11 and 12 go? 3s. Now, where do electrons 13 through 18 go? 3p. Now we've got electrons in the 3p. Now, where do electrons 19 and 20 go? 4s. I'm running out of oxygen. Now, guys, where do electrons 21 through 29 go? D, but it's not 4, it's 3. Remember, and Robert, do you get it now? The over is why it's D minus 1. So it's 3D. And now we're good. So now, guys, what do we need? Boxes. What does the 1s orbital look like? A little sphere. Draw a box. What does the 2s look like? Bigger sphere. Draw a box. What do the 3p's look like? Figure 8s. Draw how many boxes? 3. What does the 3s look like? Bigger sphere. Draw a box. What does the 3p's look like? Bigger dumbbells. Draw 3 boxes. What does the 4s look like? Bigger sphere. Draw a bigger box. Well, don't draw a bigger box, just draw a box. And then, guys, what do the 3D's look like? Wacky stuff, right? But good, Jared, there's 5 of them. Draw 5 boxes. Now, guys, you ready? We need to start drawing arrows. Guys, play along with me. Ready? Are you guys all ready to do arrows? Number 1 goes here. Where does number 2 go? Paired up, spinning down. Now, guys, electron 3 goes here. Where does electron 4 go? Paired up, spinning down. Electron 5 goes here. Where does electron 6 go? The next box over. Now we have more space, so we're going to spread out. So we've got 6, 7, then pair up 8, 9, 10. You get that? Now we're going to go 11. Where does 12 go? Paired up. Then we've got 13, 14, 15, 16, 17, 18, all paired up. Guys, what is count? Watch this. Even is now, guys, we are now at the end of the 3 sub-level. The end of the 3 sub-levels right here, so there's got to be electron 18. Then we go 19, 20. Now, guys, for copper, we need to go through 29. So we go 21, 22, 23, 24, 25, 26, 27, 28, 29. That is the orbital filling diagram for copper. Now, how do we know we're right? Guys, check this out. Here is the end of the 3D, and copper is 1 short of the end, and it's got 1 empty space. Not bad, right? So guys, grab your homework packets and let's talk. We are now going to do homework assignment number 3. So guys, homework assignment number 3, the front of this is just a retelling of your notes. Then on the back are 7 elements that you're going to do the orbital filling diagrams for. Now guys, let me just tell you about the back of this. First thought is this: I make these look really easy. If you get home and find that you're struggling with this, do that tonight. Come talk with me in the morning. I will give you an eye and I will sit down with you and help you figure these out. Guys, if you're not immediately successful with this, come get help. But guys, here's the other thing you need to know. By the end of doing this, you're going to be so sick of drawing arrows that you are going to want to hurt somebody, maybe me. Guys, understand that after this homework, you will never draw arrows again. We will replace the arrows with another way to represent electrons, but you've got to walk before you can run. Draw the arrows tonight. So guys, what do you think? Crazy, right? So guys, I'd love it if you all chose to do the extra credit. It's up to you. We'll see you Friday, and we're going to make this even better. Yep. Oh, yeah. Yep. You almost got me. Hand the Sharpies to the aisle. I like that you came back here ready to throw. All right.